Hello friends. In this opportunity, we will learn to use an SR04 ultrasound sensor module. Programming with Arduino, we can measure the distance an object is, using an inaudible sound wave, to detect objects up to 4 meters away. Using visual indicators such as LEDs or lamps, and audible indicators such as a buzzer, and defining a certain distance as a threshold, we can create a detection or proximity alarm in a very simple way. Within its various applications, we could detect the presence of a vehicle in a parking lot to determine if it is free or occupied. With the ultrasonic sensor we can also detect and count objects that pass through the detection range of the sensor very easily. For example, to detect and count the entry or exit of vehicles in a parking lot. Welcome. HC-SR04 Distance Detector Module. It consists of an ultrasonic sound emitter, which emits a non-audible wave of 40 kHz. An ultrasound receiver, which can receive ultrasonic reflection from an object. It has 2 power supply pins, 5 volts, and GND or ground. And it has 2 pins for its control, the trigger pin, for emission control, and the echo pin, for reception measurement. It is a very simple module to understand, and it works as follows. To activate the detection, the trigger pin is used. We apply an electrical pulse with 5 volts of magnitude, with a duration of 10 microseconds minimum. The module emits an ultrasonic sound wave, with a frequency of 40 kHz. This wave travels through the air, and if it finds an object in its path, it bounces off its surface in the opposite direction, and returns to the ultrasonic sensor again. The wave is captured by the sensor's receiver, and it translates it into electrical variations. On the echo pin, an electrical pulse is generated with a duration proportional to the time it took the ultrasound wave to go to the object and return to the sensor again. By measuring the duration of this pulse, with a microcontroller for example, we can apply the basic physics formula, which says, distance equals speed times time. Knowing the speed, which is determined as a constant equivalent to the speed of sound in air, that is, 340 meters per second. And knowing the time, which is equivalent to the duration of the pulse received at the pin echo, divided by 2, since the wave travels the path 2 times. Out to the object, and back to the sensor. With this information, the distance at which the object is located, can be calculated with great fidelity. In a simplified way, the distance in centimeters at which the object is, can be expressed in the following formula: the duration of the pulse of the pin echo, in microseconds, divided by 58. Or, in inches, the pulse duration of the pin echo, in microseconds, divided by 148. Bearing in mind that the physical range of the SR04 module is up to 4 meters, for distance measurement. Given its simplicity, it is very easy to use it with a microcontroller, such as an Arduino-compatible nano board, in this case. And it is ideal for mobile robotics applications, to detect obstacles and measure their distance, for example, in a robot car. Useful for object detection applications, such as vehicles and parking lots, in its standard HC-SR04 presentation, or in its waterproof outdoor presentation, the reference JSN-SR04T. And even usable in tank-level measurement applications, measuring the distance from the top of the tank to the surface of the liquid, and subtracting it from the total height of the tank, to obtain the liquid level. The above, using the presentation for outdoor and waterproof, the JSN-SR04T. This is the connection diagram that we will use for the practice, in which we will use a Nano R3 board compatible with Arduino, an HC-SR04 module, a red LED, a green one, a sound buzzer, a breadboard, and cables for connections to the breadboard. Alright folks, let's go to our Arduino IDE software to start programming. With the ultrasonic sensor connected to our Arduino board, and with the latter connected to the computer, we open a new file in the Arduino software. I recently upgraded my Arduino software to the latest version available. That is, 2.0.4, which presents us with a more stylized graphical interface, and gives us access to the tools in a more agile and intuitive way. First, we are going to install a library that allows us to operate the ultrasonic module in a very simple way. To do this, we go Tools, then we go to Manage Libraries. In the Library Manager, we make sure that Type is selected All, and that Topic is selected All. In the search bar we write Ultrasonic, and several libraries related to the ultrasonic distance sensor HC-SR04 are displayed. It is a very simple sensor to control with an Arduino, so, surely, with any of these libraries it will be very simple to use. I will select the first one that appears on the list, from the creator Eric Simoes. So, we verify which is the latest version available, in this case 3.0, and click on Install. At the end of the installation, we can close the Library Manager. To do this we go to Tools, click on the Library Manager to close this window. To include the library that we have just installed in our program, we go to the scope of the code editor. The scope is the initial space of the editor, outside of all the methods, where we can create objects, and declare variables that we will use later in our code or program. Placed in the scope, we are going to sketch or program, we are going to include library, we search and click on the ultrasonic library. Then, we create the object that will allow us to operate the ultrasonic sensor. We name it according to our preference. I will call it ultrasonic. We must specify two arguments separated by commas inside the parentheses. The first argument is the pin of the Arduino board that is connected to the trigger of the ultrasonic module, in this case pin 12, and the second argument is the pin of the Arduino that is connected to the echo of the ultrasonic module, in this case pin 13. Next, we declare the variable that we will use to store the distance readings, obtained from the ultrasonic sensor. I will name it distance. The tool we will use to observe the readings in real time, of the ultrasonic sensor, will be the serial monitor of the Arduino software, so, we will send the distance readings in centimeters, to our computer, using the physical serial interface of the Arduino, a USB cable. To do this, we go inside the void setup method, and we initialize the serial interface of the Arduino, indicating a transfer speed of our preference, in this case, with a speed of 9600 bauds, or bits per second. Then we go inside the void loop method. Remember that everything is included inside this method, will be executed cyclically or repetitively. Here, we are going to get the reading from the ultrasonic sensor, and store it in the variable distance. By default, the distance units obtained with the read method are in centimeters. If we want to obtain the distance measurements in inches, we must write the letters INC inside the parentheses, in capital letters. Then, through the serial interface, and using the print method, we are going to transmit the explicit text, distance in centimeters, a colon and a blank space. Then, through the serial interface, and using the print method, we are going to transmit the distance variable. Just to get a better visual appreciation, from the distance data we see in the serial monitor tool on the computer, we're going to put 100 milliseconds delay between each write. Then, we go to Tools, and we select the board that we are using. In my case, I will select the Nano board. And then, we select the port, in which our operating system recognizes the Arduino board that we are using, in my case, the COM3. Then, we click on the Verify icon, to review the program, and rule out any syntax errors. Then, we click on the Upload icon to upload the code to the board. Then, we go to the top right, and in the magnifying glass icon, we open the Serial Monitor tool. In the Serial Monitor, we must make sure that the transfer speed is selected at 9600 bauds, the same as the one we programmed to the serial interface of the Arduino board. On the monitor, we can already see distance readings taken from the sensor, continuously, through which we can detect objects by measuring their distance, with a range of up to 4 meters, or 400 centimeters. To continue with the programming of the object detection or proximity alarm, we start from the code or program that we have developed up to now. We momentarily close the monitor window and go to the scope of the editor. Here, we declare three variables, which associate the pins in which we have the visual and auditory indicators connected. A variable for the red LED, associated to pin number 9 of the Arduino board. A variable for the green LED, associated to pin number 8 of the Arduino board. And a variable for the buzzer, associated to pin number 7 of the Arduino board, which I will name buzzer. Then we go inside the void setup method, and with the pin mode method, we initialize the 3 pins of the Arduino board as digital outputs. The red LED pin, the green LED pin, and the buzzer pin. Then we go inside the void loop method and position the cursor one line after reading the distance from the sensor. Here we will type 2 if control structures, with which we will determine the distance limit in centimeters, from which the alarm will be activated when an object approaches. Keep in mind that this distance limit or threshold will depend on the requirements of the application you are working on. For purposes of this video, I will set a limit or threshold of 10 centimeters. For which I will type in the first if, a condition for the distance lower than 10. And I will type in the second if, a condition for the distance, greater or equal to 10. If the condition of the first if, is met, that is, that the object is at less than 10 centimeters from the sensor, I will turn on the red LED and turn off the green LED. And if the condition of the second if, is met, that is, that the object is at a distance greater than or equal to 10 centimeters from the sensor, I will turn off the red LED and turn on the green LED. As a sound generating element, we have a passive type of buzzer. Being passive, it is not enough to supply a constant voltage on it, for emitting a sound or beep. It is necessary to generate a variable signal, which produces the necessary frequency, to generate the tone that allows it to be heard. For this, we go inside the first if, and we are going to use the tone method, to generate this variable pulse type signal. In the tone method, we must specify 3 arguments separated by commas, inside the parentheses. The first argument, the pin where the buzzer is connected. The second argument, the frequency of the signal, in this case 400 Hz. And the third, the time in milliseconds, that this signal will last be exposed on the specified pin, in this case I will set 50 milliseconds. Then, we click on the upload icon, to check for errors, and upload the program to the Arduino. Then, we open the monitor if we want to observe the distance detected by the sensor. And finally, we bring the object closer to a distance below the threshold that we define, to verify the operation of the alarm, in this case 10 centimeters. Everything okay? Continuing with the programming of the object counter, we start from the code or program that we have developed up to now. Momentarily, we are going to delete the actions inside the if control structures, to better understand what we are going to program next. To count objects, we are going to use the same detection threshold of 10 centimeters that we used in the previous exercise. This means that the objects that cross the range of the ultrasonic sensor will be counted by our system, if they are at less than 10 centimeters. Remember that you will set the detection threshold, according to the requirements of your system, in a value within the available measurement range of the ultrasonic sensor, that is, between 2 centimeters and 400 centimeters. The following programming technique makes it possible to detect state changes, that is, the first instant, when the object reaches the detection threshold, in this case 10 centimeters, while it approaches the ultrasonic sensor, and, the first instant, when the object exceeds the threshold, while moving away from the sensor. This technique will serve as an anti-bounce routine, that is, it allows us to prevent the system from counting more than one object by mistake when an object passes through the sensor. To do this, we type a decision variable inside the condition of each of the 2 if structures. In the first if, we will compare it with a true value, and in the second if, we will compare it with a false value. In the action of the first if, we will assign a false value to the HC-SR variable. And in the action of the second if, we will assign a true value to the HC-SR variable. The first if detects the instant of contact of the object with the threshold, while it is getting closer. The second if detects the instant in which the object exceeds the threshold, while it is moving away. Then, we go to the scope of the editor, and globally declare the HC-SR variable, which we use in our code, and initialize it to true. We also declare a variable that allows us to store the count of the objects, in this case, counter, and we initialize it with 0. Then we return to the second if control structure, and unitarily increment the counter. We replace the explicit text that we send to the computer monitor, for the text, number of objects, and in this case, we transmit the variable counter, which is the one that keeps track of the number of objects that have passed through the sensor. We can complement the code, using the LEDs as visual indicators. Turning on the red LED, and turning off the green LED, in the first if structure, that is, when the object starts to reach the sensor range. And, turning off the red LED, and turning on the green LED in the second if structure, that is, at the end of the contact of the object with the range of the sensor. We can also complement the code, by generating a short beep on the buzzer, with a frequency of 400 Hz and a duration of 50 milliseconds, exactly when the object initially reaches the sensor range. To do this, we will type the tone method, inside the first if structure, to generate the sound or beep. Then, clicking on Upload icon, we upload the program to the Arduino board. Then, we go to the upper right part of the software and open the monitor. On the serial monitor, we can already see the system counting objects in real time. For which, we can pass objects through the sensor, at a distance less than the threshold that we established, that is, 10 centimeters, and we will see the increase of the object counter on the monitor. Well friends, I hope this video has been very useful. Subscribe to the YouTube channel and click on the bell, to be aware of new content published. A special greeting.